Hello everyone, my name is Matt Smith. I'm the head of cloud and DevOps at Ten10, and today we're going to be talking about platform engineering and why it plays a pivotal role in modernizing legacy infrastructure. So just to jump in, a little bit about myself. I've been doing this for quite a while now, starting out in a company called the Logic Group where I did payment card industries, and that was all physical data centers, PCI DSS, fully automated builds based around Red Hat. I then went on to places like Alfresco, which is an open source ECM platform, and this was back in 2012. We launched their cloud platform, which was a hosted version of enterprise content management in AWS. Moving on from there, I went to British Gas's Hive Home and launched several of their platforms over the years to get them working at scale inside Amazon Web Services. And some of them were millions of users in terms of concurrency, some were only a few, but it was an interesting story. Since then, I predominantly focused on consultancy, first with my own company Astillion, working with a core banking provider, Temenos, where we built a marketplace for their application. The marketplace was highly based on Kubernetes, particularly OpenShift for them. I then went into Tata Consultancy Services, where I worked for a number of large organizations. One of the larger ones was running an 18,000 person transformation to help them get from cloud to DevOps. So when I'm talking about why platform engineering works at these size and scales, I can do it with a little bit of authority. And today, obviously, I'm with Ten10. So with that in place, let's jump into how does platform engineering compare to DevOps. So to really understand this, I think we have to start from a principle of what is DevOps. So fundamentally, DevOps existed because we needed a way of breaking down the barrier between development and operations, and code used to just get thrown over the wall. So some code would be developed, it'd get pushed into production. The operations team would have no idea how to actually make the product run in production. They would have all sorts of issues like what settings do you apply here, there. The documentation that did exist from development was typically, how do you run it on a single instance for development purposes rather than how do you run it at size and scale. So there was that side, but there was also the other side of operations helping inform development of, well, actually, if you could tweak your code here and here, we'd get better services and better reliability in what we're doing. So DevOps was about marrying those two different ways of thinking and those two different processes together to make sure that we had a repeatable, consistent way of taking software from idea to production. And it's production that the software often has value. So the main thing with DevOps is how do you make that happen in a simple way? So if we think about the core principles, we've got to improve release consistency. Consistency is king in everything DevOps. The more repeatable you are, the more you can test against it. The frequency. The idea behind DevOps is to get the automation to a point where you can have a conversation with a customer on a Friday, and by next Friday, you've released a valuable feature for that customer. That's the principle. And you can't do that if it takes you 3 weeks to write the feature, 4 weeks to test it, 5 more weeks to actually get it into production. By the time it gets into production, that customer's forgotten you even exist. So the frequency of getting changes through is quite important, particularly from the speed in which it can happen. Communication, as we said, the barriers between dev and ops was always bad. So DevOps is a way of breaking that down by embedding the operational elements and the development elements together into the same team. We're reducing the threads of communication. So we have more people more ready and able to talk to each other, and they're hearing what everyone says on a regular basis. And this is why DevOps is very typically synonymized with agility, because you want people talking on a regular basis about what's going on and helping each other move forward. Obviously, reliability becomes an important factor as well. You want to release your products and know they're going to work in production. Again, when it comes to DevOps, consistency is king. The more consistency you have in your delivery, the more reliable things will become. Issue resolution, again, another key element of DevOps. We no longer think of issues and incidents in the same way as we used to. We don't have an incident that comes in to a first line support desk. where it gets triaged, then it goes to a second line where they might get some monitoring, and if they can fix it easily they will, and then it goes to a third line and it gets resolved. All of that's gone away. What we do in DevOps these days is an incident comes in. If it's transient, who cares? If it comes in and it's an actual problem, we delete the entire platform, we build a brand new platform from scratch, and we test to see if the issue is there. If it's still there, we roll back the code. If we've rolled back the code and the issue persists, then we make sure that the development team and everyone else who's involved in that project fixes it as a P1. So there's none of this escalation through a support process that takes 4, 6, 8 hours. This whole process happens within like an hour to rebuild it and test it and get moving again. The scientific approach, again, back to consistency. You want to be able to compare apples to apples and oranges to oranges, and you can only do that when you have consistency in your release process. So having, immutable infrastructure, having immutable configuration, having immutable applications all becomes very important, so that you can do differences between the various different levels of configuration management or code to see if changes have been made. Essentially, to sum it up, DevOps is about automating humans. We are terrible in processes. We are not consistent, we're not reliable, and we often make mistakes. So we want to remove those mistakes as much as possible and put a computer in charge, and we'll just govern the computers. The next thing I want to talk about to help get into this sort of platform engineering mindset, and hopefully a lot of you have gone through this process as well, and think about this: automation leads to products, products leads to services. So if I think about, the first few months in my career, it became very clear that we needed to understand and know if computers were even on or off. So we needed monitoring. So the way we would have done that is we would have used Nagios. We would have just put a script out there on a server that alerted us back saying it was there. And if Nagios didn't exist, it would have been trivial to create that kind of service. And that's a product, right? We've gone from having a problem to creating a product, whether it's simple or complex, to solve that. The next phase of that product is that it gets more complex, and this is where things like OpsView come in, which is an extension on top of Nagios, which then provides additional monitoring, additional reliability, additional clustering, etc., that makes Nagios more useful. But it's fundamentally still a product, but now it's a really complex product that services more needs than Nagios does out of the box. The final step is now you've got this product that services many needs across your organization. You start thinking about the usability. And as soon as you think about the usability, you're now thinking service. Because how easy is it for people to consume that product? How easy is it for them to integrate it into their services? And that's where things like Datadog come along. You just drop a JavaScript token in, or you drop a client in onto the servers, and the rest just magically happens. Very small config, you give it like a user ID, and that's it. So when we start thinking about services, it's important to realize that automation leads to products, and those products lead to services. And you probably already have products, you probably just don't realize it. You're probably thinking of them as scripts, or you're thinking of them as tools, but you need to switch that mindset from tooling and scripts into it's a product that solves a very specific purpose. And then you need to start thinking about how does that product become something that's easily consumable by people, and then how do you make sure the barrier to adopting that product becomes as low as possible, i.e. how can you turn it into a service so that people want to consume it to move forward. Now, if you find yourself in this position, then you are at the point where you have roughly the issues you should have to get into platform engineering. Your tools have evolved. They're not just scripts. They are now products that are easier to install. People can use them, but it requires a bit more effort. You are thinking about services. You're thinking about how do I make it easier for the development team in that department to just use the monitoring solution I already have. You're thinking about how do you get your DevOps processes not just across the organization, but how do you make them consistent? How do you make sure that someone in another team somewhere isn't doing a completely unique solution to Kubernetes when you already have an OpenShift version, or you standardized on ECS or something like that? So then you're starting to think about the consistency as well. Again, consistency is king. If you don't have consistency in your delivery method, then you have chaos, and then you need to resolve it. So now we need to think about how does platform engineering relate to DevOps? And it's very simple. It's just the next logical step. When it comes to DevOps, when you start having those precursor problems, you are now thinking in a platform engineering mindset. So don't let people confuse you into thinking that platform engineering is something very specific and very unique. It's not. It's really about how you're applying your DevOps principles across your organization. And because of that, you need to think very clearly around why is it better for your organization? And that's where we get into the next step. So we've talked a little bit about platform engineering, how it compares to DevOps, but we didn't cover the why. Like, why is platform engineering more applicable to larger organizations than DevOps is, particularly when we're talking about, if you have an organization with multiple thousands of developers in it, platform engineering is a lifesaver in terms of compliance, security. So let's jump into that a little bit. So if we think about a large organization, they have some challenges, and we're going to roughly bucket them into 4 areas. So communication. There's so many people, there's so many teams, they all have different problems and they all have different solutions, and all of their problems are unique and special, and they need to solve them somehow. So that's one fact. They have a lot of people. Communication is hard. The more people you have, the harder it is to communicate. The more you need to communicate to make sure a message is understood and received. As you get into a larger organization, compliance becomes a bigger issue. You have to be ISO compliant, you have to be SOC 2 compliant, you might have to be PCI DSS. So standards become something that are very important to an organization. And we often see that as frustration from a development point of view, because you're being asked to do something that doesn't make sense to you at that point. But it all comes down to, they need you to follow a certain process or a certain tool because they can tick a box to say they're ISO compliant, which keeps them happy and audited, and everyone is going to leave them alone. From a security point of view, well, now you're larger, you have more entry points, so you might start enforcing only allowing certain tools in place. You might only have certain ways of doing things because it's easier to rubber stamp, it's easier to manage it. So the typical control process is to limit down the amount of entry points, and that means the tools, the technology, because you have to have a robust process. You have to be able to demonstrate that if something went wrong, that you know why it went wrong and how. So a lot of stuff in security is not really about security. It's really about, how did it happen? Can I prove it happened somewhere? A lot of the times there is protection, but in my experience, most organizations are very, very poor at security. They're very good at compliance and auditing around it, and they're very weak on the actual security. They'll put perimeter security in place, but they won't go down to the host level, and typically they'll track logs and things. Well, if you want to have proper security, you need to have things embedded in from the ground up, and platform engineering is one way that can happen. And now let's risk mitigation. We talked about support processes earlier. It's a different way of doing things. Security, how quickly can I patch something? So a few years ago, we had things like Heartbleed. For highly mature DevOps organizations like the ones I was working in, we just pushed out a platform release. The process automatically updated every single service. And if we couldn't push out a release to just rebuild the platform, we just used our configuration management to run an update. It was very straightforward. That's not always possible in large organizations because you don't necessarily have the consistency. You might not have the same level of training in the teams. And again, if you think about having 100 different processes from a staffing point of view, you don't necessarily have something that's repeatable. It's not just click a button. It's click a button, understand X, understand Y, do something. And you need a specialist to make that happen. And even in smaller teams, people like to feel special, so they create uniqueness. And that's where we start getting into challenges. Now, if we think about DevOps kind of addresses some of these challenges, but it addresses it in an odd way. So if we think about it from a team point of view, it absolutely addresses the communication issue. You've now got everyone working in one team under one guidance. There's none of this cross-functional requirements. There's no need for the DevOps guy to go off and do something else. Their job is to make this product successful, so they're always there with the software developers to make it happen. But if you think about it from an organization point of view, if you've got, 4,000 developers, great. So now you've got maybe 250 teams. So it's slightly better because you've only got 250 different groups to communicate with, but potentially you also have 250 different ways of doing the same thing. So it's not great, but it's better. So you're great at the macro level when it comes to the actual teams, but you're not great when you look across the wider organization. You still have differences across it. Compliance, it just becomes harder because now you've got these 250 teams doing whatever they want in the way they want, and in quotes, DevOps. And I can tell you in my experience of that's where you end up in situations like putting out nightly builds of Nginx, or putting Vagrant into production, which has definitely happened to me, or putting a pre-release version of Docker into production, because the teams just decide that's what they want to do and they don't care about the risk of it. But I can tell you a multi-billion-dollar organization does care about the risk of putting out something that's not fully tested, not as fully supportable. Security becomes harder again, because now you've got 250 teams who believe they're solving that problem in their own unique way, but they're not necessarily reporting on it in a consistent way back to the central governance of the security teams. So they have a harder time tracking it. It becomes harder to see what's going on. Risk mitigation. Again, now you just have even more people doing it in a different way. So you don't necessarily address the consistency. There might be some consistency in terms of, okay, well, you might all be using Ansible for configuration management and Terraform for infrastructure as code, but you're not going to get as much consistency as you would with a platform engineering team. So let's look at how that changes it. So if you think about platform engineering, you would have a centralized team who would be responsible for creating the services and tools necessary for your organization to function. So what we mean by that is that they would be creating infrastructure as code templates potentially, or even better, an independent developer platform where you just click buttons and environments turn up. So the way of building the tools become extremely consistent, and their sole purpose is to fix each of these issues in a consistent way that works across the organization. So if your platform engineering team are producing these consistent ways of working, you get a lot better at solving these problems. So from a communication point of view, the authoritative way of doing something comes from that platform team. Anyone who's now not compliant to that is off-piste, and there's mechanisms we need to discuss how you track that, and it should be the platform team themselves who are tracking and auditing which teams are compliant. So if you imagine the 250 teams, the goal would be to have, I'd say 80% of those 250 all compliant using just the standard tools. That's the best case scenario. And the other 20% would be the responsibility of the platform engineering team to audit and to make sure they are working towards becoming compliant, or that the platform team is working towards meeting their specific user requirements to add in features and enhancements that would get them onto the platform. So you have one point of contact now when it comes to best practice and how it should be done and who is and who isn't following it. So that becomes a lot easier from the business point of view, because that platform engineering is the accountable and responsible person for making sure that there's consistency across the organization in how the infrastructure is used, how the configuration is used, how the deployments are managed. From a compliance point of view, well, what I can do now is I can guarantee, for example, that no servers in production, if there are physical EC2 instances or servers or VMs, has no users on it. So because I have that level of control, I can say, well, anyone following the platform doesn't have users in production anymore. Anyone who is using our logging is following the standard way of doing it, so we have audit compliance. So it means straight away you're bringing in this compliance, password management, being able to rotate keys. This can all be built into the same common platform, which enables you to say with certainty that the people using the platform and releasing their products with the platform are compliant, massively reducing down the amount of people who are not. Now, when it comes to security, similar principle. You can put in the processes to say, if you're doing VMs, patch them on updates. If you are using containers, then great, as part of your pipeline, AquaSec runs and you are monitoring that platform to make sure no security vulnerabilities are coming in. So you're able to build it into your release process to ensure you're being more compliant. And again, the user example, you can guarantee that certain users are not allowed access to production or other restricted areas. From a risk mitigation point of view, if you've done it well, your platform engineering approach should be at a level where your project managers on individual projects are releasing the software. That means the complexity of releasing the software, updating the software, rolling it back, rebuilding the platform should be so simple that your Scrum Master is the person that's managing the release process at this point. I'd argue that if you are not at that stage, then your platform engineering team still has work to do, because the whole point is to reduce the barrier of adoption right down so the lowest common denominator can do it. So I'm not saying that Scrum Masters are terrible people, but if a Scrum Master can understand enough about how to release the software process, your software process is about as simple as it needs to be, that anyone in the organization can release software. And that means that you have de-risked the fact that you need to be a specialist. Now anyone who can go into this portal and click a button can release the software. And that means that you've made it a lot safer and easier. So from a business point of view, we can say that all the applications, teams, services that are going through the portal, they are now compliant. It's easy to manage. Anyone in the organization can support it and roll it forwards. We just need to have new code. So when it comes to the platform engineering team, what are the key responsibilities for them, right? How do they make sure they're doing a good job? Because it's all fine and dandy, pushing out tools and technology, but is that really the right way of doing it? Who knows? So back to the core principles of DevOps, the consistency, having the improved release frequency. These are all the same principles that platform engineering teams have. But on top of that, you need to provide products and services for the whole organization that address the software delivery needs and the business needs at the same time. There's no good having, for example, let's take logging as an example. Yeah, sure, everything syslogs, great, but that doesn't necessarily meet the requirement of the security team, because they would like it not just centralized, but they'd like it easily searchable, and they'd like alerts coming off it. They'd like to intrusion detection, for example. So you might go down more of like an elk stack, and you might create some custom alerting tools, or you might integrate it with a third party. So you need to be the balancing act between what the business needs and what the developers would like, essentially. Same thing with monitoring tools and other centralized tools. You know, it's all great and dandy. Everyone would like to use their own specific tool. And, I like that as well. But we refer to that as CV++ work. It's work you're doing to learn a new tool or technology, and that's not really what's important to the business. What's important to the business is that consistency, and what's important to the platform engineering team is providing that consistency to the business while allowing the individual development teams to work in as close to freedom as they can. And that means, again, one of the core principles should be that you can follow and use the platform, and that becomes very easy. You're following the standard tools and processes, and which point, as a team, they don't have to worry. If they choose to go off piste and implement their own logging, their own security, then the platform engineering team would be the ones that say, okay, but you have to comply in this way. And that team would then have to take on the extra responsibilities of ensuring that they are compliant with the corporate policies. So it's not about saying no to doing it in a different way. It's about making sure that the teams understand that if they are doing it a different way, there are other things they need to consider. And in some cases, that barrier to adoption of doing it in a unique way is high enough that they just choose to consume the platform, which is another way of encouraging people to work in the same way. Again, this just kind of answers the compliance point here. You are now more compliant as a result of putting people through a consistent process. Now, this is quite important. You have to bear in mind the 3 rules here. People are lazy. Fundamental rule of thumb, people will typically do the least amount of work possible. So if you want people to be compliant to your processes and you want them to be compliant to security, then your platform engineering solutions need to be so easy to consume that it's a no-brainer. Once it's very easy for people to consume those services, they will just follow it. So coming back to what we just discussed, if the alternative is a 300-page document on how they need to make sure their system is security compliant, architecturally compliant, they do certain things in a certain way, versus, well, actually, we could probably just live with it working this way. If you could promise to make this change over the next 6 months, then great. You're automatically encouraging people to become compliant. But without saying no, they can still go off and do it themselves. It's just they have to put in extra work. It becomes harder to be that way. The other thing to bear in mind is that no one likes to be told what to do. So you can't go up to a team and say, hey, you need to use our platform. As soon as you do that, their instant reaction is going to be, you don't understand my tool, you don't understand my approach, you don't understand what we're doing. So I'm not going to do that. And that comes from the fact that, one, people want to feel special. Two, they also want to be creative and feel like they're building solutions. So another key tenet for the platform engineering is that you don't have to build the platform fully yourself. You might have a team who have a really advanced monitoring solution already. Beg, borrow, steal. So beg them if you can borrow it. And then once you've borrowed it and made it corporate standard, integrate it, and now all of a sudden they are contributing to your platform engineering. Allow them to push changes into your development platforms so that it can be fixed by them. All of a sudden you'll find that if there are new features that you can't quite utilize, they might just jump in and make the change themselves, or they might be more forgiving of you saying, actually, we'll get to it, but it's going to be a bit harder. So again, you have to bear in mind the barrier to adoption on a lot of this. So again, by making it a high barrier to adoption on being bespoke and unique, but a low barrier to adoption on following the standards, you'll encourage people to work in a certain way. When it comes to the final point here, again, you have to bear in mind that while we want to make sure the business gets what it needs, we don't want to make sure the business gets everything that it wants. So sometimes a business will ask for things and it's not necessarily in the best interest of the business. So what I mean by that is, let's say you've just had a security incident, or you've just released, let's talk about releases, because I can give a real example here. You've just released a product and you've had an incident. Your pipelines and everything are fine. You recovered from the incident within an hour, and the next thing you know, your CIO is saying, guys, this is unacceptable. We're going to go back to human reviews of releases because clearly something is wrong here. In that situation, as a platform engineering team, you need to very strongly tell your CIO that he has no idea what he's doing, and that is a surefire way to increase the number of issues. What you should be doing is having a scientific approach, analyze what's happened, and put in long-term fixes for those short-term failings. Might be that you were missing a test. Great. I just learned that we're missing a test. Now that test is in place, that release failure will never happen again. If we go back to human intervention, then I can't guarantee it will never happen again. All I can guarantee is the process will get slower and there will be more people involved, and people are lazy. They won't review it to the same level and same diligence every time. And as a result, we will end up with solutions that are suboptimal and release processes that are suboptimal. Now, hopefully by this point, it's clear where platform engineering should balance in terms of business and software engineering responsibility and what they should be doing. But we haven't discussed how would you actually make it work, because it is different in every organization. So if we think about a small organization, and I've said less than 100 devs, to be clear, if you've got, I don't know, let's say 2 Scrum teams of developers or 3, you probably don't need a platform engineering team. I would hope that the 4 or 5 DevOps people that you have are able to talk to each other and work in a consistent manner. If that's not the case, maybe they should form a platform engineering team. But in most cases, if we think about 100, your security compliance, your architecture, your financial controls will be outside of the development organization and controlled outside. There won't be anyone representing it internally, maybe a program manager. But I would implement a platform team that has the software engineering skills and the DevOps skills necessary to build out the infrastructure, application configurations necessary to provide services to development teams. You absolutely could have DevOps engineers in each of these dev teams as well if you wanted. I would recommend that it's probably better to have a developer who is ops savvy who is willing to work with that platform team to understand how to utilize the platform. Because when you're talking about less than 100 developers, you're not necessarily going to get the benefit of a platform team if you are embedding DevOps engineers in each one, because in theory they should be contributing to that platform team. Another option is that you have a core to that platform team of say 2 engineers, and then you have 2 that are supporting the development teams, and you rotate them on a regular basis, so the things they learn from working with the development teams they can bring back into the platform and make sure that they are pushing the extra compliances, the new ways of working. So you are governing the entire software delivery process centrally, but you're working with external people in the compliance like security, architecture, etc., to make sure that you're adhering to the financial controls, the security controls, and you are owning that release process into the development teams. Now, when we go to the medium size, you'll notice it's the same. There isn't really much difference here. Yes, you'll have more development teams, so you're going to have 20, 30 teams potentially. If that's the case, then you're at a point where having embedded DevOps engineers in the team starts making sense, because you need to consolidate their feedback in a more sensible way. So you'd probably have a DevOps engineer going across 2 teams, I'd recommend, and a platform team would then be taking those requirements and building it. The security, compliance, architecture, and finance is probably largely controlled outside of that 1,000 development area, but there will be people in there who are accountable. So you'll have some mixed stakeholder management. So you'll have the platform team reporting probably to product or program manager, as well as the CTO or CIO or chief digital officer, whoever it is looking after that. And as a result, they will be responsible for making sure that everything is working correctly, and that if you are building a new platform, it is within budget. So that FinOps side of it would still be managed within the team, but governed from outside the team. So governed on the corporate wide level. When we talk about very large organizations, so let's say 18,000 developers, you have to have a different mindset. So you have to think about, how do I provide services to the whole organization, but how do I allow each 1,000 developer chunk to be relatively self-sufficient? So here's where you would have a platform team. You could call it a center of excellence, but again, if you have a center of excellence, it suggests nothing else is excellent. So I suggest that it's more, you have a central point as a platform team who are defining and working closely with the corporate-wide finance, architecture, security teams to ensure that there is compliant tools and technologies. And then within each business unit, you could have another platform team where they are contributing to your overall platform, the same central platform, but it's a specific development team who are adding features and enhancement relevant to that business unit. And typically what we see is in these larger organizations, the financial controls, the architecture, security, compliance start becoming delegated into those business units. So there will be representatives from the wider organization who are responsible for architecture, finance, and security. And between those and the platform teams, you would work on the adherence. And again, depending on the products, the platforms, the tools, it would be very different. So you can imagine, in a large bank, they have channel-based delivery, mobile and web apps, very simple, falls into the normal DevOps sort of processes, but they'll also have insurance platforms, they'll also have mainframes. So the approaches will be very different in each business unit, but you still want them to be able to comply in some way. And that's why having platform teams in the business unit who are adapting for those specific needs and are trusted to feed those enhancements back into the core platform becomes really important. So you have like a double tier platform engineering. They would act under the reporting structure of one platform team, to be clear, but their focus is different. One is focusing on the corporate wide, the other is focusing on that business unit, and the communication between the two is how do they best service the needs of the business unit. So there's 3 priorities that you need to think of, or at least the top 3 in my mind. Priority 1 is you've got to enable the team to focus on the long-term effectiveness while mitigating short-term interruptions. So what I mean by that is that you can't simply take your platform engineering team and get them to do tactical work. If all they do is tactical work, they're never building the long-term success you need them to. So they need to have a good structure and good governance that ensures they are 100% working on technical debt and not just new feature enhancements all the time. So a good ratio would be, let's say 80-20, 20% of their time should go towards technical debt that they need to resolve. In a perfect world, that team would absolutely have dedicated software developers who are only looking at the long term. They are building the long-term solutions while you have people dealing with the short-term interruptions. So it requires an initial investment up front. That would be more of a bimodal delivery, but it's also the best way of ensuring that your platform team will get to a point where it provides value to the whole organization in a reasonable time frame. And reasonable is dependent on your organization. If you're not going to go down the custom GUI route and building your own development platform, and you're just going to string together a number of tools in a tool wrangler style, then it could be anything from 6 months to 3 years to get there. For priority 2, the mentality in the organization has to be one that supports people to fail. So we used the example earlier of if an incident happened in production and the CIO or CTO locks down and puts humans involved. That's not the right attitude. The right attitude is, yes, actually we did make a failing here, but that failing, we learned from it. So I like to say it's not success or fail, but success or learn. It is paramount not to penalize the people who are trying to drive new ways of working when they make mistakes, because why would they continue? Clearly, as an organization, you, in quotes, don't understand what that means. You don't understand the importance of doing this work. So every time you penalize your platform engineering team when they fail, you're giving the message, correctly or incorrectly, that the business does not care. So if the business doesn't care about it because they're willing to penalize the platform engineering team, you probably have a transformational issue in your organization where they don't understand the benefits of failing and learning from those failings. They don't understand that scientific approach and how it can be very consistent in driving good behaviors over the long term. Finally, this is probably the hardest thing for software engineers, a little bit easier when it comes to operations engineers. Perfection is the enemy of good enough. You do not need to be perfect in what you're doing. You need to be functional. So the way I like to look at it is, if you're trying to climb over a fence, let's rephrase that. Let's say you're trying to get to the other side of a fence. You could build a ladder, climb over it, climb down another ladder you built on the other side. Brilliant. No injuries, nothing. It takes 6 weeks, but you build 2 ladders and you can climb the fence. You could build a small step ladder, jump over the fence and take a bit of a tumble and get to the other side. Or you could just walk around the fence panel because there's a gate. So you have to think pragmatically. Sometimes you're being asked to do something, but that something doesn't mean you have to solve it in the way you're being asked. What is the value of what they're trying to get to? And bear in mind that there is no value in anything that anyone does in software engineering, cloud, or DevOps if it's not released to the end user. So any work that you do in platform engineering that doesn't make it in front of developers to use is non-valuable work. Any work those developers do that do not make it in front of the customer in the organization or outside the organization, it has zero value. It only has cost until it is in use by a customer. So the way you resolve this is you have to be very pragmatic in how you make these decisions and how you solve the problems. That enables you to create technical debt on solutions, knowing that your team have the time to come back and fix it. If you don't allow the time for them to come back and fix their technical debt, they won't create the technical debt. So you have to allow people to be pragmatic in their decisions. You have to allow them to create technical debt so that as a business, you get the benefit of moving forward at an appropriate pace while taking a minimal amount of risk. And that risk is at least catalogued, understood, and prioritized. So you have to trust your leadership around the product ownership and IT leadership to make sure they do understand that risk and are managing and mitigating it correctly. With those 3 priorities, That is how you drive the platform engineering discussion. That is how you push things to ensure that we are delivering the right kind of solutions at the right kind of pace with the right amount of pragmatism. Obviously, in every organization, it's very different, and you can end up with all sorts of varieties on this. The important thing is to always remember what your end state is. What does good look like for your organization, and keep tracking towards it. Okay, everyone. If you want to add any questions in, again, just a reminder, there's a Q&A section at the bottom. We've had a couple come in, so I'll just jump in and answer those. One of them was, if you're transitioning to a platform engineering and you need cultural change, how do you foster culture that embraces the approaches you've talked about? Culture is probably the hardest thing to change when it comes to DevOps ways of working. It requires a couple of things, a fundamental change in the business in terms of how it manages and tracks work, as well as at an individual level. So people have to go on their own journeys to understand it. So the sorts of activities that you can take, for example, is getting more lunch and learn sessions, more knowledge sharing sessions. So if you're following like a Spotify model where you have chapters and guilds, making sure those guilds and those chapters are meeting regularly, sharing information and talking to each other, making sure you do company-wide hackathons. In my experience, when it comes to cultural change, it's more about people need to understand why they need to change. Once they have that why, they're normally happy to get on board. It's very, very few people who don't want to change, don't want to get on board with that. It's more about getting people to adopt the practices, get used to the idea. There's normally resistance to change because people don't believe, for example, that you can change your release processes and simply click buttons to do X, Y, and Z, because for the last 20 years they've done it in one way. But once they start experiencing that change and they start seeing it happen, they normally get on board pretty quickly. So that's one way I would look at it. So we've got another one that's come in. Could you provide examples of organizations that have tried platform engineering but faced difficulties? What were the challenges and how could they have approached them differently? So with that question, it's a bit more challenging because every platform engineering or DevOps journey, transformation wise, they're all difficult. None of them are easy. In a lot of organizations, we just talked about the cultural change. They want to do platform engineering or DevOps, but the business struggles to get behind that change. So you have to think about what you can do rather than what the business wants. So I like to think about it in terms of spheres of influence. So you can only control what you can. So if your business doesn't want to be agile and work in a certain way, what can you do in your area to make it better? And I think just focusing on what you can do, the consistency you can bring is useful. I always tend to quote Field of Dreams here as like a film reference, because if you believe in your journey and you know what your end state is, people will get on board. And when I was at Alfresco, absolutely every single developer was very clear. They did not want an independent development platform. It was a waste of time. It was a waste of money. However, once we built that independent development platform, and once we had it so that the testers could test every single feature in parallel, we went from 3 environments to 50. They were now testing at such a pace that the development team were backlogged, not able to keep up with providing features to the testing team. And then they were like, oh, hang on, so I can just have an environment to test clustering. Of course you can. Oh, I can have an environment to test scalability. Of course you can. So all of a sudden, they were able to just spin up environments whenever they wanted to do what they needed to do and have their own bespoke environments to work on. And that's where the value starts coming to your organization, because you start getting much faster throughput because you're now reducing the amount of time. And think about the iPhone as an example here. People don't know what they need. They just think they do. So you have to produce something, demonstrate its value, and then people will start adopting it. It's one of the reasons why the barriers to adoption have to be very low. So one of the other questions here is, what tools or technologies do you recommend for building a platform? Are there specific tech stacks that align better with platform engineering? It's horses for courses. I have a preference that if you're going to do platform engineering, you should do it more from a software engineering point of view rather than a DevOps. The challenge with that is that a majority of DevOps engineers that you find in the marketplace don't have software development skills. Then they are okay at scripting things. They're okay at, say, functions and conditionals, but when you start talking about services and, you know, threading tasks, for example, that's where it gets a bit confusing. So you have to choose two ways. It is possible with things like Backstage to do it in a YAML engineering kind of way. So it's mainly configuration rather than software engineering. But I don't think you get as good a use out of it. You kind of need a custom GUI to work through it. There are some tools that are starting to come on the market that are making it a little bit easier, starting from the infrastructure point of view, but they typically don't then include your configuration management, and they don't typically get to a point where it's useful to your organization. There's a lot of bespoke need at the moment, and I'm not aware of a product that is specifically better at doing it than just doing a custom approach. And again, if you've already got DevOps in place, you probably have most of the tools and technology. You're probably just missing a service wrapper. So if you think of it as a product, get a product owner there, start thinking about how you would turn it into something that's easy to consume. Another question we have here is how to start such a transition if business does not see value in it or is not even aware it needs one. So this is a great question in the sense that in my experience, even the businesses that do want to do it don't know why they're doing it. So they know that DevOps is something that people are doing. They know cloud is helping them, and they know that it's meant to lead to more agility, but they don't actually understand the fundamental value of giving people the freedom to change and to make those changes, which is where you get the value from. You don't go to cloud to save money. That's a misconception. You go to cloud to have the ability to save money if you need to, or to scale up if you need to. Like for like, cloud often costs far more than a physical infrastructure. However, you also have far better utilization. You can turn things off. So if a business doesn't understand, then it comes down to what does the business want to do? Does it want to be agile? Does it want to do it? So in the example I gave, the 18,000 person transformation was a bank. Not all areas of that bank needed to be fully agile. There is no reason that their mainframe team should adopt a fully agile DevOps platform engineering approach to what they're doing, because frankly, if they're changing their core banking processes on a weekly basis, I as a customer would be concerned. It's not necessary. However, on their mobile apps, on their web channels, then yes, it makes sense to have those tools. To get them to understand the value, it's really about how do you respond to your customers' needs quick enough. I think during the pandemic, it was clear that businesses that were able to respond quickly were more successful. For a lot of businesses that already had work from home policies, their response was just work from home. So that flexibility, I think, is a lot more understood now than it used to be. But another way is to talk about the risk of change. A lot of organizations are scared of change, and they assume by not changing anything that they are de-risking it. But actually what's happening is you're building up technical debt, you're building up more risk, and every change that you bring is then a risky change, whereas doing smaller changes means it's much easier to identify those risks sooner. Another one here is, are the examples of team structures fixed, or have other models worked like Spotify model? Without being too disparaging of Spotify, no one does the Spotify model, even Spotify. What's happened in the last 5 or 6 years is a lot of large consultancies who will remain nameless have got behind the Spotify model as a way of transitioning organizations. But what they failed to realize is that that model increases the amount of communication. It can work on a very small scale. So we talk about the 100 dev teams, it works fine, even up to 1,000. But if you're talking 18,000 people, you're now talking about having, of those 18,000 people, something like 200 chapter leads for DevOps. So now you've got 200 people who are trying to set the direction of DevOps across the organization. And those communication threads there's too many of them. You just do not come up with a concise answer. And you end back in that same issue that you have in large organizations, which is you're debating the solutions rather than solving them. And the whole point of Spotify was that you have a small debate and you move things forward. So while some elements of it work, not all of them do, I think there's a far better team structure that can be done. In the presentation, we talked about separating work and making sure that the team has time to fix long-standing issues. So my preference is always to have a team focused on business as usual work, have a team focused on project deliverable work, and have a team focused on future work.
That way you're able to compartmentalize the value of each bit of work. If you're willing to sacrifice your service, i.e. your website, your platform as a service, or your SaaS offering, because you need to get more features done, great. But the impact is directly to your customer. If you want to sacrifice your project team, so you want to take less internal projects through, great. The business doesn't get what it needs as quickly. That's fine. If you want to sacrifice your future team, great. Then you're not going to end up with better solutions, but at least you can have conversations about where you're going to make that sacrifice. One of the rules that didn't come up in this is where I've seen a lot of challenges in organizations that refuse to prioritize work. They want everything done all the time. And as a manager in those positions, unfortunately, it's very easy to get overwhelmed. And my advice would be, if no one's making the decision, you can't get someone to make the decision, make the decision. Because if you don't make that decision, then all that happens is your team gets stressed, you don't get anything done, and you end up firefighting. And if you're firefighting, you're not improving the situation. This is a really long question, but I'm going to try and read it out. When rotating DevOps engineers from platform teams into delivery teams to generate new ideas for the platform team, can you advise how frequently you'd rotate them? Should they be fully embedded or still picking up work from the platform team? So there's two elements to this. So when I was at British Gas, we had 26 engineers who were part of the project team. So they were just working on company projects. We had a BAU team of about 2, and we had a future team of about 5. So what we would do is when a new project came up and they wanted a resource for DevOps, they never were allowed to hire their own resource. So the answer was you either hire your own, which we would then take into our team. They would go into our BAU team or our future team so they could learn what we're doing and why. And then we would give up someone from the BAU team or the future team to do it. So we had the same skill set across all the teams. They're just focusing on different areas. So when it came to rotation, at the end of those project teams, we could rotate them as necessary. But because everyone had the same set of skills, but focusing on different areas, it meant that we could rotate people relatively frequently. Project teams, in my mind, are things that run between 3 months and a year. If it's running for longer than a year, then I would suggest that you rotate people at that year point, because you need to bring innovation. One of the misconceptions a lot of large organizations have is that if you do not understand their industry, then you won't be able to work in their industry. Actually, understanding the industry is the main reason they're not progressing. If you are constrained by the things you know and things you don't know can be done, it's far easier to make progress when you're ignorant. So, for example, if you go into a large bank, they go, well, you don't understand banking. That's a good thing. Because you don't understand banking, you're asking the silly questions. And you go, well, why can't you just do X? And it'll just be things they haven't thought of. So, I think on average, I would say you should be rotating people every sort of 6 months to a year. I would not think it's acceptable to leave someone in the same role for more than 18 months. I think when you get into 18 months to 2 years, you're not necessarily bringing the innovation anymore. So it's a good idea to rotate people. So this another question here is, how can one engineer start to introduce these ideas? Do I need organization support to do it? No, you don't. So I'm a big believer of seek forgiveness and beg, borrow, and steal. Just because someone doesn't understand what you're trying to do doesn't mean that you're not doing the right thing. It's just they haven't yet understood the pain point. And if you think, as to show my age a little bit, going back to data centers, when virtualization came out, everyone knew the pain of setting up a new rack in a data center. So having a server to just add extra virtualization was amazing. But when that moved into cloud and there was no limit even on setting up virtualization, all of a sudden you start feeling cost of pain. So you now appreciate why you should manage costs in cloud. People don't understand the problems they haven't experienced. So when it comes to an individual, this is, in my view, a very good thing to be doing. And you can start very small. The more consistency you bring in, the better. The main areas to make consistent is your infrastructure as code, your application configuration, and your application itself. So if you have those three as fully immutable objects, so configuration management, infrastructure as code, you take your software product and package it up as a proper package, then you're able to introduce consistency, and that will mean scalability eventually. There are, like I said, there's tools like Backstage where once you have those components in place, you can make a clickable GUI where people can spin things up if you need to. But you have to start small. These are typically very long journeys. It takes, on average, I'd say 18 months to get to the point where the business feels the value. And even as a team who have gone through and done a lot of advanced stuff, I can tell you that the people working on it are very often not aware of the benefit they have added to the organization, because they're too busy working on the day-to-day work that they don't necessarily feel the benefit of the work they're doing, because it's a real hard uphill slog. So that's something to bear in mind. Are there any regulatory considerations when implementing platform engineering, especially in industries with strict compliance requirements like healthcare or finance? I don't think so. I think there's benefits. So if I think about PCI DSS and ITIL as two examples where you have processes that you need to be adherent to, and you need to make sure you're following the right processes, then I think it is useful to codify those issues. So for example, in PCI DSS, and the first audit I went through, they were asking, well, how many people have root access? Well, they're simple. You look at the configuration file that says how many people get given access, and that's your answer. And it's not that someone can change that, because now it's in code. And when that platform gets rebuilt, then I know exactly how many people still have access. It's the same as in the config. So by building that compliance in, it gets a lot easier. When it comes to things like data, again, it's much better to put more effort into automating the compliance, because then you can guarantee consistency. Humans are just terrible. They're not very good at working on problems. They skip processes, they move things out, and they just forget things in general. So that is quite an interesting one. So again, compliance as code, I think, is really important. Another question here. I mentioned need to be as easy as possible, but why? When we have to ensure that we follow core principles from a compliance standpoint. So the reason it has to be easy is it's a gamification point. What we need to do is make it easy for people to be compliant. If it's hard to be compliant, you end up with a divergent set of tools and technology, so your compliance becomes harder. So compliance isn't about making things easy or hard, it's about making things consistent. But if it's more likely to be easy to do it, then people will. So again, if I can click a button and build a 3-tier architecture that deploys my application in a secure way, and I know I'm automatically complying with PCI DSS, my internal processes, my internal governance, my external regulators, then why would I not do that? The alternative is I have to build all those processes, be audited internally, and it becomes harder. So by encouraging people towards that compliance through necessity, because again, if you talk about a bank, you can't release new financial products without having the regulatory approvals in place and without making sure it is compliant and it passes the security. You have to show your due diligence. But by using the platforms, you're already doing that. So I think that is all we have time for today. There's going to be a calendar link that will be shared in the chat. So if I didn't get to any of your questions, feel free to just book some time with me and we will answer the questions there one-on-one if you'd like. And I believe there's going to be a recording sent around after this as well. So thank you very much for attending. And let's say if you have any questions on this or anything else, cloud and DevOps, by all means, please just reach out through the calendar and I'm happy to talk to anyone about it. All right. Thanks very much, everyone.